This video is just a brief overview of the Outback Radian GS Load Center hybrid inverter charger system. This is the inverter and this is the distribution panel. One of the first things you'll do is you'll have to mount the inverter. Included with the system is a mounting plate. You will attach it to the wall and slide the inverter over the top of the lip that's mounted to the wall. At the bottom of the inverter, you'll see a base plate. You'll want to mount screws here. When you're installing both the back plate and the bottom plate, you'll want to make sure that you find studs for a sturdy installation. When mounting your distribution panel and inverter, you'll need to use the large bolts provided here for the inverter, for the here and for the back plate right here. You'll use these large spreader bolts to mount the distribution panel. You see at each corner there's a bulged out point that you'll mount these, and you'll need a longer drill bit, probably about 1 foot long. You've got the inverter set up on the wall. You're going to bring in the distribution panel. You'll pull in the wires right here for all the AC wiring. You'll pull it in tight, and if you come around this way, you'll see that there's 4 keyhole slots. You should line all 4 of them up. It should slide down and into spot. Once you get the distribution panel in those key slots, you'll probably need a unique way to get it tight. It is a tight spot in there. You've got a socket wrench that we're using with a Phillips head to tighten them up. So you'll have to see what works best for you or what's in your tool repertoire, but it is a little tighter fit to get that in. Distribution panel screwed on at those 4 points that we just showed you before. You're going to bring all the wires through and you're going to connect them to the tab. All these are spring-loaded tabs, so all you do is you put the wire in the hole and then flip the switch down. So when they're all in, they're all going to be laying flat. When you receive it, they're all going to be open or up like that. Also, when you're in there, you're going to have to remember to do the ground bar up front here, and you've got your mate card, or your mate cord rather. You'll put that in the remote slot right there. Here's a very crude drawing of how the Outback will lay out. As you can see, you've got the utility entering the house into the main. If you have a generator present with your system, you'll need an auto transfer switch. In the main, there'll be 2 breakers that feed the AC in of the Radian distribution panel. The AC out from the distribution panel will go to a sub panel. That's where you're going to have all your backed up and or peak loads. The solar array on the roof is going to feed a combiner where all of the solar is combined and breakered. It's going to come down to the DC in the distribution panel, which is actually going to go into the distribution panel to a charge controller. All the loads again in the sub panel are the loads that you're going to back up. When power is present, it's just going to pass through the system. When these breakers see that the grid has been interrupted, the inverters are going to automatically take over and keep these backed up or peak loads going. So if you're doing a peak load application rather than a backup application in the sub panel, is where you'd want to put all the loads that you'd want to remove during the day. This is also known as the mini grid. Here's the GS Load Center. On the far left side of the panel, right on top, you'll see all of the AC breakers and DC breakers. Also on the right side, you'll see the main 2 DC throws. First thing you'll do after getting the AC wires hooked up above in the Radian itself is you'll hook up the DC. As you can see on the top of the inverter, we've got 4 points that will be tightened with a 1/2 inch socket. On each side, there's 2 sets of those. Also on the DC side is your charge controller. The solar itself is going to come in through here to the PV1 bus bar. That's going to lead to this top breaker over here on the DC side, and it's going to go back to the charge controller. From the charge controller, that output is going to go to another breaker right below that, and will actually go from there to the battery bank. So you can see there's a series of shunts and whatnot up top. That's where all the DC FlexNet DC monitoring will come into play. This is able to monitor the solar you're producing and the amount of battery bank you have left. On the right upper side, you're going to see the AC breakers. You also see the red bypass switch. This allows you to keep power running to that sub panel in the event of servicing the system or if the system's not working quite right. On the far right, you're going to see, I should say, in the middle of the distribution panel, but on the right of the AC breakers, you're going to see leg 1 and leg 2 for your generator in. In the middle, you're going to see the grid in, leg 1 and leg 2, red and black respectively. This is actually where you're going to hook the main into the distribution panel. The AC hot out legs are right here, one black, one red. Those are going to feed the sub panel or the peak power management loads. Your Radiant system will come standard with a total of 8 AGM batteries. Usually they're group 31 as you see pictured here. Also included in your system is your parallel cabling and your series cabling for between each battery. And we give you a setup sheet so you know exactly how to wire in your batteries. For the final step in the bench test, we're going to start up the Radiant. I've given it a couple alligator clips. Then I'm going to supply it with 48 volts DC from a basic power supply that I have. First thing I'm going to do is I'm going to throw on the 2 switches. See, the mate goes through its wind up, and after it goes through its setup here, I'm going to press inverter and I'm going to turn it on. You hear that hum as it starts, and if you look right here, you'll see that it's producing, says it's producing 242 volts alternating current. So to double check, I'm going to go over to our fluke meter that I have set up at our AC in and out bus bars here and over here, and the fluke meter reads 241.3. I've got a little bit of a low battery here on my tester. If you're interested in a battery backup for your home or business, check us out online at www.backuppowersource.com.